Hey, good morning, APE students. Welcome back to our second lecture on acid ionization. I just am going to real quick go through the first couple slides where we talked about definitions of what an acid is, because we're going to be focusing on that today. So remember that acids are things that have a pH below 7. Bases greater than 7. You did that in your little simulation. And then if I have a pH of exactly 7, I have a neutral solution. We talked in general that acids can react with metals, and there's this general formula for that reaction in which we can say that a metal plus an acid is always going to form that salt plus hydrogen gas. And when I react an acid with a carbonate like calcium carbonate, CaCO3, the general reaction for that is that the acid plus the carbonate is going to break down into a salt, carbon dioxide, and water. We talked about this in the first lecture a little bit, that I look at that as a double replacement reaction. So it's easy for me to see where that calcium chloride is coming from. What happens with that H2CO3 that forms is that H2CO3 further decomposes into the carbon dioxide and water. So that's where that comes from. So we're going to dig into the definition of an acid and a base in a little bit more detail by looking at the Bronsted-Lowry definition. These are just a couple of dudes that started studying acids and noting particular behavior of them in a way of coming up with characteristics of them, describing how different substances behave in aqueous solution, and thus adding to that definition. So according to the Bronsted-Lowry definition, an acid is a substance that can donate a proton, which is a hydrogen ion, and I've kind of explained that here. Remember that when I have this hydrogen atom that has one proton and a mass of 1, a mass number of 1, and an atomic number of 1. When it loses its electron, all that's left is a proton. When you get into more biochemistry especially, like this is where you get into a lot of these reactions, but I can say a hydrogen ion or I can say a proton, and it means the same thing. A base then is the opposite of that. It is something that can accept that proton. So we can summarize that by saying that an acid-base reaction is the transfer of a proton from a proton donor, an acid, to a proton acceptor, a base. And we're going to make sense of that when we look at some actual reactions. So let's first look at this actual reaction of sulfuric acid with sodium hydroxide and distinguish what is the acid reactant and what is the base reactant. The acid, I can see when I start off with this sulfuric acid that on the product side of the equation, this substance donated a hydrogen. It lost a hydrogen, and this substance accepted a hydrogen. That's why I describe that as the base. We're going to add two more terms to our definition here, and that is the idea of a conjugate acid and a conjugate base. So we call the product that remains after an acid has donated a proton a conjugate base. In other words, it's now actually going to be able to accept a hydrogen because it gave away its hydrogen. We call the product that results when a base accepts a proton the conjugate acid. This species is now an acid because it accepted a proton, so it now has a proton it can give up. Sounds kind of confused and donated. If we go back to our definition, the product that remains after the acid donates a hydrogen is called the thing I know. So let's go through a couple examples and you'll see that this is really pretty straightforward. So I start out with all of these. There's 4 things I want to label. I'm going to label the acid and the base. Those are always going to be my reactants. And then I'm going to label a conjugate acid and a conjugate base, and those are always going to be my products. And you'll see that this is pretty much all your homework assignment is being able to label and write some reactions. So just remember the acid and the base are the reactants, and the products that form are the conjugate acid and the conjugate base. So when I look at example number 1 here, HCl ends up just being Cl minus. So I know that this starts out as my acid because it's a substance capable of donating a hydrogen. What's left on the product side after that hydrogen has conjugate base. So this is my conjugate base on the product side. It's a base because it's now capable of accepting the hydrogen. If this is my acid, this by default has to be my base, but I can also validate that with the description or definition I had of a Bronsted-Lowry definition of a base, is that it's something that's capable of accepting a hydrogen or a proton. And indeed, this went from NH3 on the reactant side to an NH4 plus or ammonium ion. This, therefore, is the conjugate acid. It's the product that results when the base accepts that proton or hydrogen. This is the conjugate acid. It now gained a hydrogen and could indeed act like an acid. And when you take AP chemistry, you'll learn a lot more about chemical equilibrium reactions, and you'll look at what happens as that reaction kind of can go forward and backwards. Let's try example number 2. On this side of the equation, I went from an OH minus to an H2O. This is a substance that was capable of accepting a hydrogen, so this is my base. This substance went from HCN to just CN minus, that cyanide ion. This, therefore, is my acid. My conjugate acid is the product that remains after that base accepted a hydrogen, and then this would be my conjugate base because it is the product that remains after the acid got rid of its hydrogen. Let's try example number 3. Sometimes you may like to pick out the acid first. That might make a little bit more sense to you because it's often the substance that obviously has a hydrogen to get rid of. So I always have on my reactant side the acid and the base. On the product side, after this nitric acid got rid of that hydrogen, what remains is the NO3 nitrate ion. Therefore, that is the conjugate base and your conjugate acid. We call this then, in summary, this reaction, when I look at this reaction between a Bronsted-Lowry acid and water, this is what we call acid ionization. And so if I have this acid, hydrofluoric acid, this water is acting like a base. We say that some substances, because we're like breaking this definition down to be, can I accept a hydrogen or give up a hydrogen? We call substances like water that have the ability to act as a hydrogen ion acceptor or a hydrogen ion donor, amphiprotic. And so in this example, here's my acid. It gave away a hydrogen. This should be the conjugate base that it formed is the fluoride ion. Water is acting as a base because it accepted an extra hydrogen. This is my conjugate, actually my conjugate acid. They just called it an acid to base in my little cut and paste. And this is the hydronium ion. It's, I think, an ion that we probably haven't worked with much yet, and one that is pretty important in acid-base chemistry. So a pretty easy one to remember. Again, hydrofluoric acid was the acid because it donated a hydrogen to form H or F minus, the conjugate base. Water acted like the base because it accepted a hydrogen and formed the conjugate acid, a substance now capable of giving up a hydrogen. And that is it for I'm sorry, we didn't talk about monoprotic and diprotic acids. I don't have anything on this on the homework. I just wanted to make you familiar. It'll become a little bit more important in our next week in our discussion. These are pretty straightforward terms. One proton or many protons. And remember, we described a proton as a hydrogen ion. So a monoprotic acid would be something like hydrochloric acid. When it ionizes in water, it has only one proton or hydrogen ion to give up. An example of a polyprotic acid, whoa, look at phosphoric acid. It has 3 protons to give up when it ionizes or reacts with water. And that'll be something that we look at more in our next lecture. So you guys should be good to go. There is a homework assignment posted. I will post the key tomorrow. And then I don't remember, I'm not looking at the syllabus. I think our live class meeting is 2 days from now on Friday, the day that your formative quiz is assigned. Have a great rest of your day. Enjoy the sun and wear sunscreen. Bye, guys.